Good afternoon, everyone. Thank you very much for joining in. For those who are in this training yesterday, thank you again for joining. For the ones who are attending the training today, we are lucky enough to have Mr. Felex Kuria as our trainer, who will be training us on the SCADA training that is used in the power supply department. So we had some questions that were asked yesterday. Today we are going to be addressing everything that was asked. And if you have any question on the call, please feel free to put them in the chat box and they'll be addressed after. Mr. Felix, if you're ready, please take us through this training.
Good afternoon, everybody. So welcome to this session. So my name is Felex Kuria, and I'll be taking you through the SCADA training. So without further ado, we can start our training. So my name is Felex Kuria. I work under track department in the Kenyan SGL, and I work under power, where we supply power to every SGL station. So I'll be taking you through the SCADA training, and I'll take you through the theoretical part and also the practical part where we do things practically. So by the end of this lesson, we will be able to know what is SCADA, and we will be able to know what are functions of SCADA, and we will be able to describe how SCADA acquires data from the field devices. Also, we will be able to list different types of SCADA. Also, we will run the future trends of SCADA technology, and also we will see what is the daily duties of an electric worker and working on Kenyan SDL. So by the end of this lesson, I will share these slides, and also you can participate using the chat section, and you can submit your question. We will address them at the end of this session. So also by the end of this training, we will be able to know what is usually inside the control room of SGL substation, and also we will understand the schematic diagram, or which is this one which I'm pointing my mouse, and also we will understand the equipment around the substation and the control room, and also we will understand their use. So also by the end of this lesson, we will understand very well what these symbols means and how do they contribute to distribute power. So also by the end of this training, we will understand how do we supply the SGL station with power, and we will also understand what is inside the high voltage room of SGL substation. So for this case, I'll be quoting Mackinnon Road because this is the place where I have worked. And to understand how we supply power to SGL stations, this is the mandate of track and signal department. And we work under track and signal department, but we work as a sub department known as power. So we have two sections. One in terms of human resource, there are people who work in substations, and there are people who work along the power line. So in order to supply power in the SGL, we have equipment, and we have also we have human working under this department, and they are organized in such a way to balance the workload. So we have 7 substations, which are 33 kV substation. So we have Mombasa West, and we have Mackinnon Road, we have Voi, we have Ngwata, and we have Simba, we have Palanai, and also we have at the River substation. And all these 33 kV, they have an external supply from Kenya Power except Ngwata. So also we have 266 kV substation, mainly one is Nairobi substation, then we have Mai, then we have 111 kV substation at Port Reitz. So for this 266 kV substation, they have 2 supply power line, and also the 11 kV also have 2 supply line, but the 33 kV substation have only 1 supply line from Kenya Power. Also, apart from supply from Kenya Power, the power department also has a power line starting from Mombasa up to Nairobi, and these substations are interconnected in such a manner to balance the load. Also, in case of power loss, we have generator which kicks when the power is gone. Also, in terms of human resource, we have people. The load is divided into sections such that people from Mombasa work along the power line up to, at this moment, they work up to Mariakani station. Also, and this is divided in section. They are responsible for generators, the power lines along the line. So that is how we supply power along the SDR line. Also, inside the 33 kV, we have various rooms, and each and every various room has equipment that are used for power transformation. So inside here we have, this is the high voltage room, and this is a 33 kV. So we have cabinets that are used to supply power, and each cabinet has its own function. And to avoid human error, and because also we are dealing with dangerous voltage, high voltage, they are most usually highly computerized to avoid human error. Also, each station has a standby generator, and each generator is calibrated according to its load, and it's usually to power the most essential equipment in the SGR line, mainly the signal equipment and the communication equipment. So, and also the power department is responsible for the maintenance of the generator, and recording each and every maintenance schedule after they have done any maintenance. So the generator maintenance is carried out each and every 2 weeks after 14 days, and you record the various parameters a record. So we will go directly into our topic of the day, the SCADA training. And in our world today, everything is becoming digitalized, and the computer have changed and they have advanced in terms of software and hardware, and each and every industry is trying to take advantage of this advancement, and we want to have an economy whereby each and every, you can get every information of any data you have, and you can convert it. So the world is changing, and the software and hardware is rapidly changing, and we are trying to have an economy-based economy such that everything is digitalized, and many industries have analog equipment. So we are trying to digitalize everything, and with computers you are able to control everything well, and also acquire data when you are using computers. And SCADA is a form of control which we usually use in electrical power generation and transmission. And SCADA is an acronym of supervisory control and data acquisition. So that is the meaning of SCADA. So SCADA is a control system, and we can ask ourselves, what is a control system? So a control system, we can break it down to two parts. One is what is control, and the other part is what is a system. So to control is to regulate or to command or to direct a thing. Also, a system is a connection of things interconnected to form an entity. So a control system is a combination of control and a system. So to understand a control system, what is control system further, we can understand it in terms of inputs and outputs, such that when you want to control something, you must input the signal, and you will have an input. So there are two types of control system. One is man-made, and the other one is natural, and we have the third type, which is hybrid, a combination of man-made and natural. So also we have open and closed loop system, and in our picture here we have a closed loop system. This one, the one I'm pointing. So it has input, then this rectangle represent control system, then this arrow represent output, then this arrow represent feedback. So a closed loop system usually have feedback, but our open control loop system only have input and output. So to understand better, we can give an analogy of a water pump, and using a water pump using a float switch. So the float switch is connected together with the water pump, and it is usually to control the level of a fluid in a tank. So the float switch is calibrated in such a way when the liquid is below is almost empty, the float switch will turn on the water pump, and the water pump will pump the water until the float switch indicates now the water is at almost full level. So it will send a signal to the water pump, and the float switch will turn off the water pump and water will stop flowing. So that is an example of a control system. So also we can also give another example of a human body. Human body is also a natural control system, such that your body responds to changes in your environment. And maybe if an insect bites you, that sensation will send a signal to your brain, and your brain will tell your eyes to check where you have been bitten. So that is an example of a natural control system. So SCADA is a form of control system, but now we have introduced computers and we have networked our equipment such that we can be able to communicate with various equipment. So as we have defined what is SCADA, so we will go to what are function of SCADA. So, and the function of SCADA are to get them right. You can just get them from the name SCADA, which means supervisory control and data acquisition. So the SCADA it is usually used to gather data and to control equipment that we have deployed in the field. Also, we can also record events which happens. We can record events which happens in the field. Also, we can communicate with the field devices such that we can turn them on or off. Also, we can, after acquiring this data from the field, we are able to present them in such a way human beings can understand, and we can use this data to make future decisions. So we have industries that use the SCADA. We have energy industries, and for this example, we can give Kenya Generating Company. It usually use SCADA to generate power and also to transmit the power. Also, we have oil and gas industry. They use the SCADA system to be able to drill oil and to get data while mining oil. Then we have the transport industry. So for this we can give an example about the Kenyan SGR. The Kenyan SGR uses the SCADA system to plan train routes and also to control the signal routes, the signal that are on railway track. So we have also food and beverage industry. They use this SCADA system to maybe refill their fluids. And for this example, we can give a Coca-Cola. Coca-Cola heavily uses SCADA. Then we have recycling industry. They use this to recycle maybe metal parts, and those are the industries that use SCADA. So we will go to the next part, which is what is the types of SCADA system, and this type of SCADA system are categorized according to their when they were invented. The monolithic type was the first part to be invented. Then we have the decentralized system. Then we have the networked system, and we have IoT SCADA system. And IoT means the Internet of Things SCADA system. So in SCADA, the substation are networked so that they can communicate together. So the Internet of Things is the new type of SCADA that, and I can give a brief about it because this is where the future is coming to be. So in terms of, because now the world has internet, you can connect your SCADA system on the internet, and you can control it wherever you are. And for this part, we have a small computer which is called Arduino Uno, which you can use to make an Internet of Things type of SCADA system. So for further reading, you can learn about this when I share the slides. So we will go to the other question, the other objective we had on this training. How does SCADA acquire data in the field? So in order to know how SCADA acquire data from the field, we will first learn the basic components that comprises of a SCADA system. So one, we have sensors and actuators, or the field devices. Also, we have PLC or RTU, and I will define them I will define this component data. Also, we have a human machine interface. So let's go and define each and every part. So the sensors, as I have said earlier, they are field devices that help us to get the digital signals from digital or analog signal in the field. So an example of a sensor, we have temperature sensor, we have relays, we have humidity sensors, and these field devices, they usually collect data. They can collect it either in form of a digital signal or an analog signal. Also, they help us indicate the state of our field devices. So these sensors are connected together with RTU, and the RTU is connected together with the human machine interface. So we will go to, so this is an example of a relay. So we will go to what is PLC or RTU. So RTU is an acronym meaning remote terminal unit, and this is a field devices which is interconnected together with the sensors, and the main function of RTU or PLC is to monitor, control, and connect field devices such that we can be able to get those signals. And also, when it gets those signals, they are converted to either digital format, and then the RTU is connected to the human machine interface. But RTU is the most wins over PLC because you can program it using C# language, and also in terms of power backup, RTU also is very rigid, but PLC, to program it, you need to know about the ladder programming language, which is not an easy task to know. So after acquiring data in the field, we need to communicate it to our maybe to other equipment. So to communicate, we can communicate using either satellites. You can use fibers, optic fiber, or Ethernet cables, and also you can use radio waves. So this is we will go to the part of human machine interface, and we will learn a human machine interface is a display of the field devices, and because we can't see all the field device, we can't go to the field and just see the state of the field devices. We can be able to see them using a computer, and this computer has a software that is interlinked with the RTU, so that we can know how is the state of operation of each field devices. So we will learn further about this and how you can switch off power. So we will learn also what usually happens in a control room, and maybe duties and responsibility of electric work and working under as a 33 kV substation. So this is a control room, and also this is a different view of the control room, and it has various panels that are here to indicate the state, to which each and every one has its own function. So RTU, we have discussed about it. So this RTU is interconnected with this computer or the HMI, and this RTU also is connected to the high voltage side. And also we have panel number 2. This is AC panel, and we have panel number 3 and panel number 4. This panel, they function the same. Their function is to supply power to RTU, and maybe when there is no power, the battery side will operate. But before it goes to the battery side, we have a generator backup. So this button, the one I'm pointing my mouse, is the Kenya power supply line. So if supply power line is off, the generator will kick, and this indicator will turn to red. But if we have problems from Kenya Power and also from the generator, then our battery bank will kick in and power the RTU. So for number 5, we have a metering panel. This metering panel is on Kenya Power side. It indicates power coming in from Kenya Power, and usually we collect data each and every day, and also on monthly basis on power that has been consumed on substation. So on panel number 6, we have a compensation panel that is connected with another machine, which I will show you in an upcoming slide. So this is the battery bank that we have in a substation, and there are 18 batteries, each with 12 volts, and or they have each of them have a capacity of 101 ampere hour. So they are connected in series, and they are used to power the RTU in case of power failure between the generator and the power supply side from Kenya Power. So also we have a device here which is at the back of the DC panel, and it is connected with the batteries such that we are able to get the data from batteries, that is voltage and the current from batteries. So that device help us to acquire those data, and those data we can see them at the front side of the battery panel. It has a small screen, and it has charging voltage and charging current. So we usually collect this data each and every day on 8-hour period of time. Also, the computer is able to get data from the batteries. So at this point, we can see it has a charging voltage of 250.6 voltage, and we have a control bus bar of 230.1. We usually collect this data each and every day, and I will show you where we usually let them on our daily record. So this is our RTU, and I will show you the backside on how the connection are done. So this is how the RTU is connected, such that it can be able to communicate with the high voltage equipment, and also is able to communicate either to our computer or a computer in Nairobi for control of power. Also, this is the front side. This is the front side of the panel number 6, which is used for power compensation, and this is done because the power is transmitted over long distances, and due to that there is a power loss. So we have this machine to compensate power, and you can control it either on manual control or on remote control, but our substation is usually on remote control, so that nobody can. So it is much easier to control. Also, we have button here indicating whether it's running or start or is off. At this point, it was running. Also, we have this button, which you can either change it to local or remote, such that by what I mean by local, you can change it. Maybe by local we mean manual. You can change it to manual, then you can operate these buttons. But at this moment, it's connected to remote, such that you can control it using the computer. So this is the machine that is used for compensation of power loss, and there are usually 2 of them. So each and every machine has its own room. So this has its own room, and also this one has its own room. They are connected with the computer and the N6 panel to compensate power. So these were the front side of our panel. So we will go to high voltage side. But before we go to high voltage side, this equipment emit a lot of heat, and the substation has two power conditioning. It has two air conditioner to keep them cool at room temperature. So this is our high voltage room, and as I said earlier, we will know the function of each cabinet. So these cabinets are interconnected in such a manner they share power. So, and also you can control them using the computer to switch them off or on, and also you can use the manual side to control them here, not on the control room. And also this substation has 3 power source such that we can get power from Mombasa, or we can get power from Nairobi, from Voi, or we get external power from Kenya Power. So we will discuss on that part, on how the power is supplied using this schematic. So the N2, this is where the Kenya Power comes into our substation. So its function is to supply power to all these other cabinets, and N1 is usually used to power the equipment that we have in the substation. It has an inbuilt transformer that transforms the 33 kV, which is supplied by Kenya Power, to 415 voltage, and is used in the substation room. So N3 is the bus tie, which is connected to these other cabinets, such that the power can come from this side and travel along the bus bar to these cabinets. Also, we have N9. N9 is the power source from Voi side, and also N10 is power from Mombasa side. So on this schematic, we usually use it to simulate and indicate the power state of various equipment. At this point, at the green side, green button means this N10 power is turned off, but the red button means the power is on. Also, N6 panel is used to supply power to various equipments around the SGL substation, maybe the communication equipment, and also the staff rooms, and also the signal room. So N7 is connected to the power reactor room, which is used to power compensate due to losses for long distance transmission. Also on this part, this is the graphical representation of what we have discussed, but on computer. So this computer, we usually use it to turn off power remotely instead of going to the high voltage room and turning off power. So this is the N1, and this is N2, and this is N3, and this is N4, N6, and so on. But at this point, the N8 is turned off, and you can see, according to this line, the power is not going through up to the bottom, and because of that, this point is black. Also, this rectangle represents the circuit breaker, And at this point, you can check at number 10 is turned off. And these two arrows represent the hand cut switch, which I will show you in the next slide. And also in this video, I will show you how to turn off power and turn it on using the computer. So now we understand what these numbers means. So now we can proceed and try to learn how to turn off power. And there is various ways to make sure this N2 and N9 and N10, they don't meet, because we have different power supply sources. So to turn off power, we usually come we select the cabinet we want to turn off power, and for this demonstration we will use N9, and it's calibrated such that you can't just press on this button and turn off power. There is a mechanism on how to do it. So you will come at the bottom of this screen. You will see a button indicated to Nairobi direction, and you will click on that button, and it will give you this menu. And when we have this menu, you click on the N9 sign, and it will open this menu, which requires two passwords so that you can execute power. So the password are usually one. The one is for the operator, and also the other one is for the guardian. So those passwords are different. So after you have turned off the power, the circuit breaker will change. If it was red, it will change to green, as an example of this N10. So that is how we turn off power on using the computer. And also the SCADA software is installed in the computers, and this is how you log in to that menu. We have an icon which is called SCADA Start. You will click on this SCADA Start, and it will open this menu where you will input your password as an operator, which is usually one, or the username will be one and the password will be one. So as I was saying earlier, if you click on these graphic interfaces without following that procedure that I have just shown, this error message will appear. So also on the high voltage side, if you turn off power, this circuit breaker switch will turn maybe to green if it was on. So at this point it was on, and when we switched it off, it turned to green. Also in the high voltage room, we have a earth switch, which is, if you want to operate on the high voltage cabinet, you must turn this switch on. so that the excess voltage is grounded. So this is the point you will come with your tool and turn it off. At this point, we have a LED color to indicate it's open, and also on this high voltage cabinet display, we can also see it's turned on. So this is the hand cut switch, and we usually turn it on or off by inserting our tool here at this point and rotate such that the switch either moves at the front side or at the back. When it moves to the front side, we turn it on, we turn it off. But when we push it in, it is turned on, and it is indicated on this display as we can see it here. So this is the tool we usually use to move the hand cut, this one with the white color. And this one is used to turn off the add switch. So we will go and discuss further on what is on N6. N6, we have a transformer which is connected at this point, and it's connected in star delta connection, and it transforms power from 33 kV to 415 kV, and that 415 kV is distributed among various equipment, such as the building we have around the station, and the equipment may be like water pumps. So this is the transformer, and it has its own room, and this side is the high voltage side, and this side is the low voltage side for 15 volts. And this equipment is usually, the maintenance of it is carried out once per year under the mandate of Nairobi Electric Club. So this is the low voltage cabinet. It's such that power from the transformer, it will enter to this cabinet, and these cabinets then supply power to various equipment. So for this point, we have each and every cabinet, each and every switch here, the black one, it supply, maybe we have one supplying the sewage pump, we have another one supplying the freshwater pump, and we have another one supplying the kitchen pump, the kitchen room, and each cabinet has a 415 volts, and it has a circuit breaker calibrated according to its load. Also, each cabinet has its own meter to understand the power consumption of each equipment. So these readings are usually collected monthly on how various buildings and equipment have used power. Also, on the high voltage side, we have, this is the metering panel. It is on the high voltage room on those cabinets, such that we can be able to collect the power consumption of each and every cabinet. So we usually collect data on intervals of 8 hours, and we do power consumption calculation and draw load curve on daily basis. So to collect the active, we usually collect the active power and the reactive power. So this is the procedure we use to collect those data. we usually press at Q, then enter. We have this menu. Then you press enter. Then you press at the fourth item. That is where you will find the active and reactive power data. So this is the menu where you will collect the data about power consumption. And this meter, they are in such a way they can collect data if power is running on, maybe from Macron to Mombasa. They can collect data in if the power is connected in a negative side, such that I can give an example such that Macron Road is supplying power to Mombasa. Then you will collect data which starts with plus. But if Mombasa is giving power to Macron Road, you will collect data using the data that has that start with a negative sign. So for N2, the N2 cabinet does not have this metering panel, and its metering panel is connected at the control room, and we usually also collect data, which first one is the active power, and we press these buttons until we have these codes, this 000. Then we have the readings for active power. Then for reactive, we usually press those buttons until you see a code with 5, then you record this data. So I will show you how we record. We record them on this operation log. So for a case, if you have collected data on N2, you will come and indicate it on this column. If it was 8 a.m., you will indicate it at leading part. Then you will compute them and draw a load curve here. And this is the operation log we usually write daily. And at this point, this is where we write about the storage batteries. And at this point, we usually write anything that has happened on the substation, the important notes. Maybe power was off or power was on. You indicate the time and the time the power came back. So also here we write about the data about the batteries, the charging voltage, the floating current, the power bus bar, and the control bus bar voltage. We usually write them here at an interval of 8 hours. So we have come to the end of our training, and this is my email in case you want to get in touch, and maybe you can collect few questions. So we have various questions here.
Alex?
Yeah.
So I see the questions that were asked yesterday, the ones that you've missed. There's a new one. There's a new question in there in the chat box.
Yes.
I think this is more of a comment. Can the questions that you didn't answer yesterday?
Okay, let me share them. Let me look for them and then answer.
Okay.
So I will answer the question that we had yesterday, which I did not answer. The one was, can you tell us how far can we supply power between substations? So the way we supply power along the SGR line, the Mombasa West substation is supposed to supply power from Mombasa up to Mackinnon Road. Then the Mackinnon Road substation is supposed to supply power from Mackinnon Road up to Voi, then Voi to Ngwata, Ngwata to Simba, then Simba to Palanai. That is how the substations are connected and they are able to balance the load to supply power. Then we had another one, which was, what are the periodic reading you do take in the substation? So let me share my screen. So this is the operation log we usually use to collect data in the substation, and we usually collect data after every 8 hours. You can start at 8 a.m. and 2 p.m., then 8 p.m. And we collect data on various cabinets. So we collect data from, let me show you the schematic diagram. So we collect data on N2, and we collect data on N1, N2, and N6, N7, and N9 and N10. Then we record them on our operation log, and we also write the reading here. Hope you can see. Here we have reading part, and also when we do the computation, you write the kilowatts here, either if they were kilowatts or the kVR. So those were the questions we had yesterday.
So a couple more questions.
Yeah.
Just open the chat box. We can answer the ones that you're able to answer. If you find that you have any difficulties, you can just say that we are going to send correct answers in a later time. So we have a total of 10 questions. You can just go through them and answer the ones that you can.
So I can see them.
Recording in progress.
So I can answer the number 9 question, which says mention the various interlocked to be observed during the switching operation. So let me answer that question. So maybe because of safety measures, we have 3 power sources in our substation. We have Kenya Power side, and Kenya Power side is on N2, and on N9 we have power from Voice station, and N10 we have power from Mombasa West station, Mombasa West substation. So this N2, this is power from our substation, our KPLC substation in Maungu, and it is a different power source, so they can't meet together, because we will have the power will blow. So for our case, maybe we want to use the power from Mombasa. So to use power from Mombasa, we, in this state of this operation, I'm assuming this is the operation of the SGR substation. The first thing that we will do, we will come into N3 and we will turn off the power to this side, such that it can't meet. So this N2 will be, this N2 and N1 will be isolated if we turn off the N3. And also if N10 was off, we will just turn it on. We will first come and turn N9 off, and then we will turn N10 on, and the power will flow to this bus bar, and our substation will have power. So our substation, because we have this panel help us to separate the section of power, so that power can't meet. So I think those were the questions that I can see on my side.
So, Felix, I don't think the other questions were addressed yesterday. You know, like there's this question that is saying that could you mention the 11 kV box type SS and its components? Were those addressed yesterday?
So I can see it. So the box type is usually used to supply power where we don't have substations, and it is usually connected to the 33 kV. For this case, I can give an example. We have a box type but this at this point is a 33 kV a box type in Miasenyi substation, and it is usually used to supply power to the equipments and the building, the railway station in Miasenyi. So I can see another one. What are the technical challenges you have been having between your SCADA and Kenya Power System with regards to billing and load? So I can say at Macron Road there is no technical challenges in terms of power supply, and the power is usually stable and we don't have many challenges regarding our load. But sometimes in case we supply power to Voi side, and also we supply power to Mombasa side, the power usually turns off itself at the substation and not on the Kenya Power side. So when the substation at some times, and this is due to unavoidable circumstances such that we don't have power at Mombasa, and we at Macno Road we have power, so we usually send power to the Mombasa side, and when it is connected between those two stations, our station usually have the power turns off itself at N3. So I think those are the questions. So I have another question on mention the local and remote selection that you have to set on the cabinet or switch gear before doing any switching of operation. So let me share my screen to answer that. So in case maybe you are going to operate on this high voltage side and not on the computer, and I have demonstrated how to do it on computer and safety precaution that you have to follow. So on the high voltage side, at the moment, so here at this side of our display, we have a button which you can, if you are going to operate it on the high voltage side, there is a point where you change it to local or remote. So this is the at this moment I don't have that picture on how to turn it local to remote. So those are the questions I can answer at the moment.
Okay, I will record these questions as well, just like we did yesterday, and then you can compile the answers. You can type them in either Word or something, and then we will share them to the people in the power department. I think that one will serve each and everyone. So if that's it, you can answer for now. That's still okay. Record all of them and just do more research. We'll share the answers with the team.
Okay.
Okay, thank you very much, everyone, for joining in. We really appreciate participation in this, and we would really want to encourage you all to keep participating, keep asking questions, and keep making these trainings more useful. So, Mr. Felix, thank you very much for your time. We really appreciate it. You've taken 2 days of your time to take us through this training, and we can see the efforts that you've given into it. Thank you very much. See you next time. Thank you.